All right, so for module 3, you have to know how to do exponential calculation. So, okay. So, Julie, do you know how to do a conversion to and from the percentages? Like, do you know how to convert a fraction to a decimal? And, okay. Hold on. Okay, let's see. She took away from me, so. Okay, let's see. Gotta go back to my meeting. Sorry, Julie. Okay. Okay. So, okay. So then I'm gonna skip that one. So these things you gotta be able to do. Oh, there she is. Annie, can you talk now? Can you hear me? You should be able to. Okay. So there are two different changes. One is called the absolute change, which is just the difference between two numbers. But there's a relative change, which is a percentage change, and there's a formula for that. So you can use the middle one, the new minus original divided by the original number, or you can just do new number divided by the original number minus 1 to get the change, the relative change. So for example, let's say you have a shirt that's 24 bucks last week, so that's the original number, and it's on sale for 18 bucks this week, so that's the new number. What is the discount rate? It's asking for the relative change. So what you do is use this formula right here. It's probably the easiest one, the far right one, where you divide a new number divided by original number and subtract 1. So in this case, it's going to be 18 divided by 24 minus 1. And if you do that calculation in your calculator, you get negative 0.25. So that's the relative change. You can convert that to a percentage, multiply by 100, so that makes it a negative 25%, or you can say 25% off. So that's how you do relative change. So the relative change could be, well, either one. The change could be a positive number or negative number. So if it's a negative, that's a discount. If it's positive, that's the increase. Okay. Do you have any questions there? Okay, sounds good. Moving on. So the key thing in this module is the interest rates. You probably know what that is. It's basically the time value of money. So the interest is the price you pay in order for you to wait. So when you wait to use your money, there's a price paid for waiting, and what that is the interest rate. Okay, so there are a couple two different ones basically. There's a simple interest and then compound interest, and then the principal means it's the original balance. So if you borrow $100, that's the principal of $100. So there are two types of interest. calculations. One is called a simple interest and compound interest. So we'll do the compound a little bit later, but the simple one is simple interest because it's very simple. So the formula is, so the A is accumulated balance, P is the principal, the I is the interest, the T is the time. If you're asked to do simple interest, just multiply the principal, the interest rate, and then the time. So in this case, if you borrow $100 at the rate of 10% for 5 years, so that principal is $100, 10% is the interest rate, and then time is 5 years. So you can do two calculations at the end of 1 year, at the end of the 5th year. So just do 100 times 0.10 times 1, that's 10. So that's $10. That's the interest. So if you, after 1 year, you owe $110. If you do the math for 5 years, it's going to be 100 times 0.10 times 5, which is 50. So you just add on to the original amount, so which is 100, so $150. So that's simple interest rate. The thing about the interest or simple interest is that the interest amount is the same every year, so $10 per year. So they accumulate to be 50 after 5 years. So that's the simple interest rate. Pretty simple. Do you have any questions there? Okay. So the compound interest, there are a couple different types, so I'm going to go through each one of those. Compound means that the interest is accumulated at a certain interval, so it could be daily, monthly, yearly, exponentially. So there's a new terminology for a compound interest, which is the APR, which is the annual percentage rate. That's you've probably seen that in the bank statements and such. The Y is typically the number of years, but that could be different. So the general formula for that is principal multiplied by 1 plus the rate, raise it to the Y or the T here. Okay. So let's say it's, go back to the simple interest rate, the same thing, but it's compounded annually. So then punch in this formula at 100 times 1 plus 0.10 raised to the 1 power. If you punch that in your calculator, you should get 110. And if you do say the same thing for the 5 years, it's 100 multiplied by 1 plus 1 or 0.10 raised to the 5th power. So if you do that calculation in your calculator, you should get, if you chop it off at 2 decimal points, 161.05. Can you? So Julie, can you try that and see if you get that 161.05? Make sure you know how to do that. I'm going to wait for you for a minute and see if you get it. Okay. So yeah, so you just got to do what you just did for the rest of the session. Okay. So this is, you use this section right here if the interest is compounded annually. So like every year, if it's compounded annually, you use what we just did. Many times the interest is compounded multiple times a year, so usually monthly, but it could be quarterly or daily or whatever it is. So if the interest rate is multiplied or compounded multiple times within the year, here's a formula. Okay. Same principle. A is accumulated value, P is the principal, APR is the rate it's given to you. N is the number times the interest is compounded within the year. So if it's 12 times a year, N will be 12. If it's quarterly, then it's going to be 4 times, so it's going to be 4 down here. If it's daily, it's going to be 365 down here. And then raise it to n times y. So whatever the n is, if it's 12 or 365, whatever it is, multiply that by the number of years that you have. So for example, if you want to calculate the interest, well, the accumulated value of interest for a deposit of $5,000 that pays an APR of 3% compounded monthly, what's the accumulated value after 5 years? So in this case, the P will be 5,000. APR be 3%, so that change that to a decimal. You got to change it to decimal, so it's going to be 0.03. It's monthly, so it's going to be 12 times a year, and then after 5 years, so the Y is going to be 5. So basically, you do this calculation, just plug it into the formula, 5,000 times 1 plus 0.03 divided by 12. Raise that to 5 times 12. So if you do the math, it's going to be raised to 60, power 60, and then 0.03 divided by 12 is 0.0025. So punch all that into your calculator. See if you get 580808. So you should try this, Julie, just to make sure you get that. Okay. So I'll give you a minute to do that. Okay, sounds good. So sometimes this part right here, APR divided by n, whatever that value is, in this case 0.0025, that's called a periodic interest rate. So if you're asked to calculate the periodic interest rate, that's how you do it. Just divide the APR divided by how many times you're compounding. Okay, so that's how you do periodic interest rate. So this works for any number of n. N could be 12, 365, whatever it is. So if that's the case, just use this formula right here. The last case is if the interest is compounded continuously, so not 365, but just ongoing basis, then it's called a continuously compounded interest rate. And then we use the special function called the exponential, so it's a little e. So it's accumulated values p times e, which should be in your calculator, raise it to the APR times y value. So this is, if you have a TI-30, this is how you do it. But do you see this e to the x kind of looking thing on your calculator, Julie? I don't know which calculator you have, but like on the iPhone, it's e to the x power. Do you see it? Okay, sounds good. So this one's a little tricky to do. So I recommend you try this first. So let's say you're doing the interest rate calculation for 10 years after a $100 deposit with the APR of 8%. So typically people get confused on this part. So you should do is multiply the APR times y. So in this case, 0.08 times 10, so which is 0.8. Do the e to the 0.8 part, e to the raised to the 0.8 part first to get 2.22554, whatever it is on your calculator, and then multiply by 100, whatever the principal is. So you kind of go reverse. Do e to the 0.8 first, and then multiply 100. So see if you can get 225 and 55 cents. Okay, so I'm gonna wait for you to do that part. So if you're asked to do continuously compounded interest, this is what you do right here. Okay, rock on, okay. So the last thing I'm gonna cover is this fixed deferred annuity formula. So if you're, I don't know how old you are, but if you ever retire, you might get an annuity. And it's deferred because you don't get the annuity till after you retire. So you'll be asked to figure out this, calculate the fixed annuity. And then the formula for that is this humongous thing here. So the L is the future value of the last payment. So typically for an annuity, you make a same amount of payment for over a period of time. And it accumulates interest, the periodic interest rate. And then the T is the total number of payments. So if you, let's say, for example, you make a monthly payment for 5 years. So that means the T will be 12 times 5, which is 60. So T in this case is the total number of payments, however many you make. So let's do an example. So then if you're asked to figure out the annuity, it's typically the future value. So future value of a college trust fund where you deposit $100 every month for the next 12 years or 18 years. And let's say the interest pays 6%, and the interest is compounded monthly. Assuming the last deposit does not generate interest because it's the very last payment, there's no time to generate any kind of interest at that point. What would be the future value of this annuity? Well, you just plug into the formula. L in this case will be 100. P will be, it says that, what's it? Let's see. Well, P is the periodic interest rate, so you have to figure out that periodic interest rate. And then T in this case will be 260 payments because it's 18 times 12 years. Or sorry, 18 years times 12 months, so that's 216 payments. The periodic rate will be the same formula as above, which will be 0.06 divided by 12, so that will be 0.005. L is 100 because that's the deposit amount. So if you plug it into the formula, you should get this number. So it's rather complicated. So what I recommend you do is you do the top part first. This part right here. I don't know if you can see it, but 1 plus 1.005. Raise that to a 216. Calculate that, and then subtract 1. And then divide that whole thing by 0.005, and then multiply that by 100. See if your end result is this amount, 38,735. Okay, so I'll give you a few seconds to do this. And if you do, then you can do the assignment. It's pretty easy. Oh, yeah, okay. Either way, yeah, just practice it and make sure you get this. You know, punch it in and make sure you get this. Yeah, that one's a rather complicated. So yeah, if you can do it in Excel, that's great. Okay, so let me just make sure I covered everything. So it says percentages. Yeah, okay, percentages. What was the percentage increase or increase in the tuition? We did that. Simple interest, we did that. Annual interest, so let's see. Okay, that's the annual compounding, so that's number 4. And number 5 is monthly compounding. We did all that too. So you should be able to do the assignments pretty fast. We cover all the formulas. So basically the key thing is you punch in the right numbers in the right place. Okay. Do you have any questions, Julie? Okay. Then you can take off. I'm gonna try to talk to Annie and see if she can hear me. But oh, okay. So Annie is responding to me. So I'm gonna stop the recording.